Hi, Michael.
Hello, thermodynamics. Yay.
Yay.
All right. So our we were assigned problem 7.4, and basically just to start right away, uh, they asked us to find two types of temperature: the boil temperature and the inversion temperature for gaseous methane. Okay, so knowing that, and also of course they gave us they gave us the information for T and B. Okay, so um, to begin, obviously I wrote down graph data points on an application, of course, Wolfram, and to do so, we need to graph B and T, right? But like I said, from the given information, we have B and T, but we need to graph the inverse of T. So obviously, of course, just take each T value and do 1 over T, and then that will be your new data point. And then from there, you just graph B as Y and T as X. And then once that's all plotted, and I believe it's over there, but that's okay. So the once that's plotted, that's an approximately 504 Kelvin. That's for the boil temperature. Now, in the problem, in the same problem, it says for the inversion temperature, it says the temperature at which dt over dph is equal to 0. So right away we notice, all right, so we need to find dt over dp. We need to find a relationship with that. So we started off by saying we started off with the triple product rule right here with dt over dph and all that. And from there we isolated dt over dph by moving dividing the other two um the other two to the other side. And we tried to see if there was any relationship between the two, and we noticed that dt over dhp is actually 1 over cp. So that helped us a lot. And then from there, we noticed there really wasn't a relationship with dh over dpt, but we know what dh is. So once you derive dh in terms of dp, you go over here and you see that that is equal to T ds over dpt plus V dp over dpt. And whenever you have dp over dp, or when you have dp over dp or something, two same things, of course it's equal to 1. All right, and then from there, like I said, we have T ds over dpt plus V. And then once again, we look for another relationship with ds over dpt, and we know that that is actually equal to negative dv over dtp. So that helps us a lot, because from there we plug it in and we end up with dh over dpt is equal to negative t dv over dtp plus v. And from there we go and substitute everything that we found, like the 1 over cp and what we just solved for dh over dpt, and we are left with dt over dph is equal to t dv over dtp minus v over cp. So we're getting closer to being able to actually solve for the inversion temperature. So from there, um, and actually the so virial EOS, in the problem, it actually states that it states that uh, there's an equation that can be written as PV is equal to RT plus BP. And when you isolate V by itself, you're actually left with right here, V is equal to RT over P plus B. That is very important because if you remember earlier, we had dV over dTP. So we have an equation for V, so let's derive it, and we'll get derive it in terms of t, which will go over here. So we have dv over dtp is equal to rt over p plus db over dtp. And then now we can go and substitute that back into the equation that we just found on the first slide. And once we do that, and we manipulate the equation throughout the whole thing, we are left with, right here, we are left with t times db over dtp minus b over cp. Okay, so again, that is super important because again, in the problem is stated we need to do dt over dph when it's equal to 0. So now we set that equation equal to 0 because then because we have all the things that we need in order to find t. So when we solve again, we multiply CP to the other side. And then we get 0 is equal to dB over dTp minus B over T. Okay, and then we just basically manipulate it and we end up with a relationship between B and T. From there, um, like I said, we already know B, and we can find dB over dt P with B. B is this very long equation. This is actually the equation that was found when we graphed the boil temperature over here, finding 504 Kelvin. Okay, so once you find once so we just wrote that out again, and we took the derivative of it, and that's our of course that's dB over dTp. And from there we went back and substituted um, dB over dTp, and we of course have to multiply it by t because that's what our equation had in it. And from there, now we can officially set b is equal to 0. The reason why we're doing that is because again we want to find t. Um, that's how we're gonna find t. So we set it equal to 0, and we basically just solve the quadratic equation, and we get t is equal to approximately 958 Kelvin. So that is how you find the inversion temperature and the boil temperature.
All right. So what we'll then do is go on to part B, which we did completely through MATLAB, as it was a lot of very similar calculations to part A, and just to kind of speed it up, quickly go through in MATLAB. So we started off by filling out our variables, where W is equal to 0.011, R constant, we had PC, TC, and we had all of our time or all of our temperatures. Um, we knew that TR was equal to T divided by C, so we had that put in there so that way we would get our TRs for all of our different temperatures. We have the equation for B0 or B naught is 0.083 minus 0.422 divided by TR to the power of 1.6. So that will give us a whole bunch of different B naughts for each of our temperatures. We have B1, which is equal to 0.139 minus 0.172 divided by T divided by TR to the power of 4.2. That'll give us all of our B1s. And with all of those, we can plug that into the B equation to get B is equal to B naught plus W times B1 multiplied by RTC divided by PC. And that would give us everything we needed to plot down our problem. We wanted to plot down inverse T versus B, and that is what we ended up getting for part B is our blue line. And for part A, we have the dotted orange line. And you can see they're very similar, but they're not exact. Right here is where it differs the most, I would say. But they are both very similar graphs, but not identical, which is a very important thing to know. All right, and that's everything.
Thank you
Yeah,
for
hope you guys
listening.
enjoyed.
Yep.
All right, everyone have a good day. Bye.